Hey guys, how you all doing today? Hope you enjoyed your spring break. I'm sure you missed me. I missed you guys just a little bit, not much. But yeah, I'm sure you missed having math work to do, and I hope your Easter went well on Sunday and everything. I know it's unorthodox, but you got to make the best of what it is. So I think we're on the decline now. I think we may have a chance of coming back to school now. I guess we'll see. Maybe the numbers are going to jump back up. I don't know. It's hard to tell. But I miss you guys. Hopefully I get to see you soon. So we've been talking about logarithms and exponential equations here. Last week we did a segment on solving exponential equations. This week we're going to solve logarithmic equations. There's two things that we need to keep in mind that are very useful to us, and those are our inverse properties that we learned a while back. Okay, this was a few weeks ago. If you're struggling to remember these, just jump back and watch that video. It's still on there. Should be able to help you out. So the inverse properties, the first one is if our base number and then the base of our log is the same thing. And whoa, take it easy. In this case, so like 2 to the power of log base 2, all that goes away and it just leaves you with whatever the exponent is. Same for number 2 here. If the base of the log and then the whole number of the log are the same number, those can go away, just leaving you with whatever the exponent was. So those are two things that are going to be very important to us moving forward here. Okay, so I'm just going to jump right into these and work through these examples. Hopefully they should be able to answer all of your questions that you might have. I did look through the work and these pretty well match. The only thing that, there's one thing that I'm not going to do an example on. I want you to be able to kind of try and figure it out, and I'm going to talk about it right before we stop. So example 1. I've got the natural log of 3x equals 2. Now, this problem fits into the form that I could jump this over into exponential and then back solve it from there. But it's actually way easier for me to do because it's way easier for me to use these inverse properties. Because what's actually going on is this is log base e, so there's a little e there. I know we don't write that. But what we can do is we can make e the base of the exponent. So we can turn that entire problem into an exponent. Okay, the whole left side we can turn into an exponent. Why are we allowed to do that? Because as long as we do it to both sides, we can do anything we want. I can multiply both sides by pizza, and you've seen me do it before. But I don't need to in this case. It's not going to help me. But as long as I make both sides exponents, then it will work. So on the left side, I have e to the power of natural log of 3x. And on the right side, I have e squared. Okay. So what happens is this goes right along with inverse property number 1. E to the power of log base e goes away, only leaving you with the stuff that was in the exponent. Now on the right side, we've just got to take into consideration what we have. We have e squared. That's a decimal. I'll type it in a second, but for now I'm just going to say e squared. Okay, the only thing I've got to do to get x by itself is divide by 3. So 3 goes away. X is whatever e squared divided by 3 is. Let me get you a number for that. That's e squared divided by 3. It turns out to be 2.46. Feel free to answer that as e squared over 3 if you want, or the decimal, okay? It does not matter to me. I know some of you don't really have great calculators, so if you want to leave it as e squared over 3, that's fine. Your phone calculator, if you turn it sideways, actually does have an e, so you should be able to do it that way if you struggle. Let's look at example 2. Okay, example 2 works out really well for us because both of these things on both sides have the same base. If we did not have the same base, we'd be pretty well in trouble. You won't be given a problem that does not have the same base, okay? So you would not be working with something like this, okay? So what we can do here is we can just make everything exponents again, and we can choose what we want the base number to be. Over here on example 1, we chose it to be e because it worked best for us. But here, if we just make everything 3 to the power, and then on the right side 3 to the power, that lets this log go away, that lets this log go away, only leaving us with the other stuff that's left in there. So I've got 5x minus 1 on the left, x plus 7 on the right, and then I can solve a simple equation. So I'm going to put all the x's on the left. So that'll leave me with 4x on the left. I'm going to take this 1 over. So 1 would be gone. On the right side, I got 7 and 1. That would be 8. So brought the x over to the left, 4x. Took the 1 over to the right. That's 8. I'll divide by 4. Let me get me some room here. So x would be 2. Okay, so I think you'll find that these problems are really not bad. And once you figure out the method that goes along with it, you should be good to go. Now, the one thing that you have to consider about a problem like example 2 is if you had stuff with that, you would not be able to do it. So that's going to come up here in a little bit. But if you're going to create a situation where you're putting in a number and making something the exponent, that has to be the only thing that's on that side, and you're going to have to cancel everything with it. So you've got to manipulate your problem to make it match. That comes up in example 3 here. Take a look at example 3. I can't just willy-nilly be putting an e in here and canceling it out with that natural log, because number one, I've got the 5 over here that's in real bad shape. That's making the whole problem struggle. But I've also got that 2 that's in front of it. Okay, so e to the 2 natural log doesn't match. It doesn't let stuff cancel out. So what you have to do is isolate your log before you get started. So let's move 5 over. Take it over to the other side. So I got 2 natural log of x is -1. I like to just go ahead and take the 2 over to the other side. Some people like to, let me see which way the book does it. Some people like to take the 2 up to the exponent, make it natural log of x squared. I don't think it's necessary for this problem. Yeah, the book takes it over to the other side. You'll end up getting the same thing, okay? But I would rather just get it out of our way so that we don't even have to worry about it. So I'm going to divide it over. I get the natural log of x is -1/2. So then now I can take into consideration what the base of the exponent is. So the base of the log is e, so I can do e to the power of natural log, which cancels out, just leave me with x. So then on the other side I would have e to the -1/2. You can answer it like that if you want, or you can say e to the -1, half is 0.606. So 0.606. If I had moved it up to the exponent, I would have got natural log of x squared is equal to -1. Then I would have done the e thing. Okay, so then I would have had x squared is e to the negative first, and then I would have had to square root it. It's going to end up giving me the same thing anyway. Okay, so whichever way you want to go, doesn't matter to me. All right, so hopefully that made good sense to you. Down here in example 4, I got a similar situation, but what I'm going to end up with is a little bit of extra steps. Okay, so I've got 2 times the log base 5 of 3x. I can't just throw a 5 in there until I get the log by itself, so 2's got to leave. Okay, so I've got log base 5 of 3x first. 4 divided by 2 on the right is going to give me 2. At this point, I'm allowed to put my 5 in there to cancel out the log, and I'll do it on both sides. So I've got 3x is equal to 5 squared, which is 25. Now, ordinarily, the problem would be over. If you take a look back up here, after we created that bottom number, on most of these problems, it just outputted us the answer. On this one, we've got a little bit of extra. Okay, so we've got to do something with this 3. We'll divide it over. So x would end up being whatever 25 divided by 3 is. 8.3. Feel free to answer it as 25 over 3 if you want. So keep in mind that you might have an extra step at the end, such as dividing by the 3 like you did in this problem. All right. Now, I don't know what has happened to this handwriting. My iPad has changed this handwriting. This is natural log of x minus 2. Let me fix that. Looks like a child wrote that. Natural log of x minus 2. Let me check my book, make sure that's the problem I want to do. Yeah, natural log of x minus 2. All right, so this is the problem that I was talking about where we've got to do some stuff. Okay, so we're not allowed to just throw e's in here. Okay, if I was to put an e here, and move the 2 and do an e here, yes, it would get rid of all the natural logs, but it's not legal. It's legal on the right, but it's not legal on the left because I've got 2 things that are added together. Okay, so I can't just put more than one base of the exponent. I can only do that one time per side. So it's just not a thing. Okay, but I can get around that by combining these 2 logs. You know the properties of logarithms, when you have 2 logs added together, the things inside them are multiplied. So what I have is the natural log of x minus 2, let me put it in big brackets, times 2x minus 3. That looks bad. Let me start over. Oh, crap. Now I erased half of this. All right, so I've got the natural log of x minus 2 times 2x minus 3. Okay, I just combined those logs into one log because they were 2 logs added together and you multiply the stuff inside. I'm going to go ahead and move this 2 up to the exponent here. Remember, that's a property of logarithms that you're allowed to do. I could divide it over the other side, but then it would really be in the way on the other side. So in this problem, it's easier to just put it in the exponent. At this point, I've got a log on both sides, so I can do my exponent thing and get rid of all this and just leave myself with the stuff that's in here. So x minus 2, 2x minus 3, that's all equal to x squared. Now, this problem has quite a bit left to do. We've got a FOIL. We'll probably end up factoring if you can see the future. So this would be 2x squared minus 3x minus 4x plus 6, x squared. I'm going to bring this guy over. So I'm going to subtract x squared. So it'd be x squared minus 7x plus 6. Factor. X, 6, 1. I'm sure you understand the point of this problem is to get rid of the logs, and from here you can work on it because you know what to do. We've been solving quadratics like this forever. So this will output you two answers, 1 and 6. There are extraneous solutions in these. They come up in just making logs not work. Okay, this problem actually does have an extraneous solution. 1 is extraneous. Because it makes a situation that does not work. I don't need you to check for extraneous solutions. It's not really that vital. Nobody's life is depending on it in these situations. So just give me your answers and don't worry about doing your extraneous. So hopefully you were able to follow that. The moral of the story is put all your logs together to get into one log on each side before you start doing exponent stuff, because if not, it does not work out. If you would have done the thing from the very beginning there that I said, put 3 e's in, you'd have had x minus 2, and then you would have probably tried to add 2x minus 3 to it and combine those like terms and then moved it over the other side. It would have been a disaster. It won't work out, I promise you. Okay, so now the only other thing that you have to do that I'm not going to show you, I want you to think about, is if you had to combine two logs that were subtracted. Now, you know that you would divide them, and then how to go about solving from there, I want you to just consider. Probably what your best option would be is to multiply the denominator over to the other side and distribute whatever you have, or FOIL if you have to, and then go from there. But just look at that. That's the way I would go at it, so a little tip there just in case. Okay, so hopefully you were able to follow me on solving these logarithmic equations. Remember, use your inverse properties. If you're struggling to remember those, go back and find the video where we talked about the inverse properties, and you should be able to find some stuff on that. Okay, so let's talk about problems. I think what would be a good idea for us would be page 217. Let's work on 37 through 46 and 93 through 114. I feel bad. That's quite a few. Maybe we should call Eli and see if he wants to bargain on it. Here, I'll get him on the phone. Your call has been forwarded to. Oh, I can't believe it. He sent me a voicemail. All right, so Eli had his chance. He was going to bargain on it, but oh well. I guess we'll just do these. So you'll hear from me again next week, and get these turned in to me. Should be good to go. Let me know if you got any questions. Send me a message. I can send you over a video or a screenshot or whatever you need. Hope you guys are doing well. Hopefully